Hello everyone! Today we'll be looking into the end behaviors of polynomials. When a problem asks for the end behavior of certain polynomials, it is basically asking for a description of the ends of the graph as the x values approach negative infinity and positive infinity. In our first example here, we have a graph of a function with a positive leading coefficient and an exponent value of 2. And as the x values become increasingly positive, we can see that the graph rises to the right, and as the x values become increasingly negative, the graph also rises but to the left. To put it into mathematical terms, as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches positive infinity. From the answer choices, option C is our answer. For our second example, we have a graph of a function with a positive leading coefficient and an exponent value of 3. Once again, to figure out the end behaviors of this graph, we must provide a general description of the ends. As the x values become increasingly positive, the graph can be seen rising to the right, but as the x values become increasingly negative, the graph falls to the left. In mathematical terms, as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x also approaches negative infinity. Therefore, B is our final answer. Now, what happens if we use a bigger exponent like the one in our third example here? This function has a positive leading coefficient and an exponent of 4. The middle part of the graph is clearly different than our first example, with an exponent of 2. This is because this function has more zeros, in other words, when the graph intersects the x-axis. However, we are interested in the end behaviors of these polynomials, so it does not matter how many solutions the middle of these graphs portray, but rather the general behaviors of the ends of the graph. When we focus on the ends of this graph, as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches positive infinity. Therefore, our answer is C. In this fourth example, we use an even bigger exponent of 7 with a positive coefficient. Once again, since we are only looking for the end behavior of these graphs, we disregard the middle part of the graph and focus on the general ending values. As the x values of this graph become increasingly positive, the graph rises to the right, and as x values become increasingly negative, the graph falls to the left. From the answer choices, B is our best option. Now for this next example, we have a negative leading coefficient with an even exponent of 4. When the leading coefficient of a polynomial is negative, the end behaviors of the graph is different than if the leading coefficient is positive. As we observe the ends of this graph, it can be said that as x approaches positive infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x also approaches negative infinity. Our answer is D. Once more, we have a polynomial with a negative leading coefficient, with an odd exponent of 3 this time, however. Like example 2, where we determine the end behavior of a polynomial with an odd exponent and a positive leading coefficient. The graph rose to the right and fell to the left. In this case, however, our graph falls to the right as x values become increasingly positive and rises to the left as x values become increasingly negative. Therefore, our answer is A. Overall, the takeaway rules of the end behavior of polynomials is that the end behaviors of each polynomial is dependent upon the value of the leading coefficient and the exponent. If the exponent is even and the leading coefficient is positive, the graph will rise to the left and rise to the right. If the exponent is even, but the coefficient is negative, the graph will fall to the left and fall to the right. Now, if the exponent is odd and the coefficient is positive, the graph will fall to the left and rise to the right. If the exponent is odd and the coefficient is negative, the graph will rise to the left and fall to the right. And that concludes my presentation. Thank you for watching.